Thanks for watching me, and thanks, Adam, for getting this together and inviting me to chat. This is going to be a little bit different than thumbs up. Thanks. This is going to be a little bit different, I think, than the standard talks that are here. It's not going to be too techy. Kind of two reasons why. One, I can't talk too much right now about the tech that smartARM sort of has under the hood. It's still a little bit under wraps, unfortunately, but two, I think that there's a really interesting conversation to be had relating to smartARM and the topics that these talks are sort of supposed to center around drones and robots and computer vision, which is sort of, I guess, the title there, Beyond Novelty, but really is centered around how to avoid the curse of getting distracted by excitement and novelty in consumer-oriented robotics and consumer technology. So before I go in on that, I'm Evan. I'm one of the co-founders, and I head product development here at smartARM. Basically, what we do is we make the world's first bionic arm for the limb different community that's powered by computer vision. So instead of using an array of EMG electrodes to control a prosthetic arm, which is how it's currently being done in the industry, we use computer vision. And a bunch of different cameras and optical sensors embedded in our arm to make it work. And the goal around smartARM is also to make these products as accessible as possible, which sort of ties together the topic of this talk. So the reason why I wanted to talk about this specifically, which is a more product-oriented conversation rather than technology per se, is for two main reasons. I think, and two main reasons why I think this is important to talk about. One is that robotics, and I mix drones in there too, and obviously computer vision these days is used in both of those pretty ubiquitously, are really, really, really difficult to pull off. Not only are they difficult to build and just make work well from an engineering perspective, they're extremely difficult to build as companies. Too, and I think that what I'm going to talk about here is something that compounds that, and is compounded by the difficulty of building robotics and building advanced consumer technology. And I don't think that we need to make it harder on ourselves. I think there's a lot of really talented people, a lot of really hard work, and a lot of money that sort of goes to waste by falling into the trap of novelty and excitement in technology like this. And the two is that I think that there's a lot of really, really powerful and useful products that are thought of and built every year that, again, go to the wayside because people don't necessarily take the time to think about how those products might scale effectively. And I think that actually, conversely, using the concepts within computer vision and within advanced drones and robotics, the general scalability potential of technology is a really good way to introduce really valuable products into the market in a sustainable and effective way. So that's a lot of words, but I'll sort of give you a couple pieces of context as to what I mean by all this. So the first example I have, just to sort of start off, are these two news clippings. I literally just Googled these and found them, and I thought they were pretty funny. These are real newspaper clippings. The one on the left is from 1940. And with the headline, "Performing Robot Earns Money for Its Owner." And I thought that this was really funny because this is a headline that you would see still today. That robot, although pretty clunky, doesn't look too far off from some of the stuff that we see today as well. And obviously we don't see this robot walking the streets these days. So obviously we know that it didn't turn out too well for that lad who built it. And the one on the right, obviously, is I mean, it's probably a bit of a joke. I hope it was. Robot cow moves and gives milk. This was a robot actually that was unveiled at the World Fair back in 1933, I think it says. And then the idea of this robot is that it would input ingredients and spit out milk that you could then drink. Two examples of pieces of tech that took some really big brains to try to make, were extremely advanced for their times, and no one really cared about it. This is important because we see this happening today still. And I don't mean to pick on these products again. Like it's very hard to build effective robotic technology and effective robots that people actually want. But these are two recent examples of robots that have sort of flopped expectations once they were launched. Pepper was launched by SoftBank, and they had promised that this robot was going to change the world and change how we interacted with technology. It didn't. The interesting thing is it actually sold out when it was first launched for pre-sale. Again, because it had that novelty and excitement factor around it, there weren't too many units sold after that. And I think that SoftBank has significantly reduced its attention towards robotics since then. The one on the right there, LG's robot, I think you pronounce it Chloe, it might be something different. Unfortunately, when they debuted it in 2018, there was a lot of buzz around it. Again, a lot of hype. It flopped during its demos, and then subsequently went on to sort of not be too successful in the market. They sort of revamped it in 2022. You can see best inventions it got in time. They're now focusing more on industrial use cases, which I mean I hope goes better for them. But only time will tell. Again, these are two examples of pieces of technology that took a lot of capital, a lot of really smart people to build, and were extremely difficult to build and to get to a point where they could be produced and shipped in a way that was theoretically useful for people. But unfortunately, when it got into the hands of the people that were meant to use it and people that paid real money for them, they realized that they just weren't useful to them whatsoever. And you can find examples like this all over the place. These are two that I took off a quick Google search. But unfortunately, I think because robotics, drones, pieces of advanced technology, we see this with the fad of AI going on right now too, are so exciting and so easy to talk about and get excited about. We see all of these resources being used towards products that really don't need to exist and end up not existing going into the future. Okay, on the other hand, there are a lot of other low-tech examples of products and pieces of technology that are quite valuable or could be very useful to people, but just for some reason do not have the potential to exist sustainably in the market for whatever reason. So these are examples of some projects that I worked on during my time at university. Very quickly, basically, instead of going to class over my 4 years, I would use these as an excuse to skip class and work on them. So these are just a few examples that I pulled from my camera roll back in the day. The one on the top left is a modular walker meant for children with physical impairments, and just made of PVC pipe. And then the idea is that you would ship it to families in developing countries with kids who needed a walker to help them move around. For super cheap. The one on the right is a toy to help children with visual impairments learn how to read Braille. Braille literacy is on the decline, and so this was meant to help mitigate that. The one on the bottom left is a pill dispenser meant to keep medication secure using fingerprint tech. And the one on the bottom right was a assistive device meant to help people with poor mobility get in and out of their car safely. Now, I really enjoyed building each of these, and each of these are things when we show them to the users that they were meant for, got them really excited because they would be an extremely valuable tool in their lives that would help them live more autonomously. The problem is that unbeknownst to my naive self, they really didn't have much potential in the market as a standalone product, and each of them really required some pretty radical thinking when it came to business model or branding or whatever it be, to actually make them work. And at the end of the day, if you can't make something last sustainably in the marketplace, it's not useful to anyone. And so the top two there, they just had weak markets. There's not too many people that they would be useful for, and so they would require some really interesting business model sort of considerations to make them work. The one on the bottom left, the pill dispenser, that was just a bad idea, honestly. It just created more problems than it fixed. And people that we showed it to, they thought it was cool, but it was opened us up to some pretty big lawsuits, I think. And then the one on the bottom right, the car one, just has slow growth potential. And so this is an example of how the same concept of novelty distracted myself and the people that I was working with to build these things. In many cases, significantly funded by the university that I went to. Blinded by excitement, we sort of pursued these for long periods of time, used a lot of capital to produce them, and then realized afterwards that excitement sort of distracted us from looking at the bigger picture and seeing whether or not these products could actually stand alone in the market and at the end of the day be useful to more than one person. So that brings me to the connection here is through prosthetics, obviously. There's no better example of this than in prosthetics, to be honest with you. If you just do a quick Google for 3D printed prosthetic, it seems like everybody that gets a 3D printer, the first thing they try to make is a prosthetic hand for some reason. And if you Google that, you might go all the way back to 2018 and you'll see a janky version of smartARM on there as well. These are examples of really well-intentioned devices that were created by really, really smart people. And they had one of two pitfalls. Either they weren't functional enough to actually be usable, but two, the interesting things with all of them is that people who make prosthetic arms also tend not to want to sell them for very much. And so all of these were built with the goal of making them as accessible as possible. And usually that means selling them for as cheaply as possible. The problem with selling something very cheap, especially something like a prosthetic arm that doesn't have a crazy huge volume of people worldwide that would want to or that would need to use them, is that again the business fundamentals just aren't there to sustain them in the long term. So smartARM, where does this come in with us? So back in 2018, my brilliant co-founder Hamal, he had the idea, talking to a friend that he had who had an upper limb difference, for smartARM. And he was talking to this friend, and she was basically explaining how there's a dichotomy in the industry where you'll have devices that are fairly highly functioning, but extremely expensive. We're talking about $75,000 all the way. We had someone in our office the other day that had a $200,000 setup on their arm. So incredibly inaccessible. In fact, 95% of amputees around the world cannot access these devices. On the other hand, you'll have very simple devices, that are sort of just meant for cosmetic purposes, that are a little bit cheaper. They're still fairly inaccessible, but a little bit cheaper. But the retention rates on those are extremely low, again, because they really don't do very much. So the idea back then was okay, how do I fix the issue of performance in these? Because even the more advanced devices, they definitely still have room to improve. Well, it was, let's make a hand that can see instead of relying on unreliable biosignals like EMG detection to make this hand work. Let's automate the whole thing. We'll use computer vision and AI to detect all the objects in the vicinity of the user and determine how best to interact with them. The other piece of that was, okay, how do we get these into the hands of people in an accessible way? We don't want to be charging $100,000 for our device. We don't want to go for a high price, low volume model. We want these to be used by every single person in the world who desires to use one. And so obviously that meant charging a little bit less for it. Well, how do we do that? Oh, my light's going off. Apologies. That's what happens when you're on a motion sensor light. Okay, so how do we get it into the hands of more people more accessibly? Well, you charge less for it, but how do we charge less for it while making sure that we can still grow a large business that investors are going to want to invest in? Well, we use the scalability and the growth potential of the technology that's inherent in the product for the functionality. This is Sakai. This is our very first user. She's a very good example of the average upper limb prosthetic user. Arms are too expensive. They still underperform. So this is what we built for her. The world's first bionic arm powered by AI and computer vision to solve her problem. And the cool thing is that, yeah, while that works really well, you can imagine that if we're collecting data about if we're collecting data about how humans are interacting with the world around them, and we have a camera and optical sensors helping us do that, then we're actually starting to quantify how humans are effectively being dexterous in their environments. And if we can start to quantify human dexterity, then we can start to apply that to other forms of robotics and other products down the line. Can't say too much about our plans there, but that actually incentivizes us to get this on to as many people as possible, because like the common Tesla model, for example, each one of these are data acquisition vehicles. And so that means that although we're charging less money for these devices right now, which enables us to get it into the hands of more people, the scale at which we're doing that actually builds the strength of our technology and allows us to scale the business of smartARM past just the product of the prosthetic itself. And it allows us to roll out a lot of different other technologies that can be really useful to people down the line. And so that's sort of our spin on taking this really valuable product that could be really useful to people, charging not very much for it, but doing so in a way that actually incentivizes us as a profit-making business down the line for years to come.